Beautiful people, and welcome. This is part 2 of your understanding quadratic functions and equations. As always, if I make a mistake, please let me know where the mistake occurs so that way we may learn from it. All right, let's jump in. This is just a recap of what we did in part 1. Let's determine what each of these are called. I'm just going to highlight your x and y axis so you can separate that from your line of symmetry or axis of symmetry. So this here is your x-axis. This one here is your y-axis. So this dotted line right here, this is imaginary. Mathematicians are lazy. We don't typically see this when we have a quadratic equation or a quadratic graph sketch. However, this is called your axis of symmetry. Sometimes you'll hear it as your line of symmetry. I sometimes say that, but it is your axis of symmetry. Since we have these two on the x-axis, these are your x-intercepts. This point right here on the tip of the curve, this is your vertex. And then this point right here is on the y-axis, so therefore it is your y-intercept. So in the previous video, we talked about our vertical changes, things going up, down. We talked about your vertical stretches, things being stretched vertically versus being stepped on and compressed vertically. Today in this video, we're talking about your horizontal shifts. So let's look at our parent function. So our parent function is f of x is equal to the square root, is equal to x squared. There is a secret bubble that is holding x outside of the squared. And so what happens when we put a h in there that is positive? So let's say we have f of x is equal to x plus h, and then that is squared. So I'm going to circle this plus h. Make sure you take the symbol with it. And the best way that you're going to think about things that are inside the parentheses, that are inside the function, that are inside the square, is that you're going to think opposite of what you see. So if you see a plus, that means you actually have a minus. So that means you are doing the opposite. You are going left, h amount. So what happens when you have a plus h? For example, notice I have a plus 3. That means I am going left 3 jumps. So our original, let me sketch our original parent function. Here it is. So imagine if I was to pick up this blue curve and go 1, 2, 3. 3 jumps. 1, 2, 3. Here's my new vertex, and here's my new graph. So what happens if I don't have a plus? What happens if I have a minus? So when we have a minus, again, let's take it. We're going to do opposite of what we see, right? So we have, think opposite. So if I see a minus, that means I'm doing the opposite. I am going towards the positives now. So I am going to the right h amount. This is called a horizontal shift. So if this here is my parent function, I'm just going to quickly sketch it out. I'm going to the right. Let's see, if I have a minus 3, I'm going to the right 1, 2, 3 jumps, and here's my new vertex. Now what happens if we combine all of these? The vertical shift and compressions, the horizontal shifts, what happens? So let's go ahead and transcribe these. So a lot of times you'll get questions with these type of transformations is describe the transformation. Basically, we are taking a mathematical sentence. We are now going to change it into an English using English words. This is how I would like for you to do it. Take every single piece of the equation and circle it. So I have a minus. I have an a value that's being multiplied. I have an h value with the symbol. And I have a k value we're taking with the symbol. So what does this all mean? If it is inside the bubble, if it is inside the parentheses, this is your horizontal. Now, let's draft this out here real quick. And not the equation, but I just wanted to give you the x-axis and the y-axis. This is your horizontal line. That means this one here is your vertical. So if you have a horizontal, that means your options are either going to the left or to the right. But anytime you have a horizontal shift, you are thinking opposite. And you are only thinking opposite for the horizontal. So if you see a +4, reality, you're not going to the positives, you're going to the negatives. So you are shifting left 4 jumps. Now everything outside of this horizontal bubble, this inside function, everything outside of it is you do exactly what it says. So if you see a -5, that's vertical, so that means you're going down 5. This 3 that you are multiplying, you know, when you multiply numbers, they get bigger, so that means you have a vertical stretch. Let me see if I can spell stretch. By 3. Again, you have to write by what? You can't just stretch it. You need to tell me how much you're stretching. And this negative out in front tells me you have a reflection. Let me see if I can get another color. Reflection across the x-axis. So each little piece of the equation tells you to do something. Let's do it one more time. Again, circle every single piece. Here is, oh, I forgot a squared here. This should be squared because that is what our parent looks like. This is our inside. That means we're thinking opposite. We have a -8 inside. We have a positive 3/5 here. And we have a +7 here. So we have 3 things happening. So if we are working inside, we're thinking opposite. So this is a -8. We are not going to the negatives. That means we're going to the right because we're thinking opposite. So this is right, 8. This one here is a +7. It is not inside the function. It is outside. So therefore, we are going now up 7. And notice that this is a fraction. This fraction is between, taking the absolute value of it, is between 0 and 1. That means there is a compression, vertical compression by the factor of 3/5. All right, beautiful people, thank you so much for watching. We will do plenty examples in class. As always, have a wonderful day.